walking on stage to Metallica or something like that. How many people here, I can't see anything, but how many people here are Salesforce customers or have heard of, okay, Salesforce customers first. Thank you very much for being Salesforce customers. How many people have heard of Salesforce? Everybody, good. I'm not supposed to give a sales pitch, so it's really good that you know about us already, so I don't have to do anything that has to do with a sales pitch. So, those of you who are Salesforce customers already, we have a big show. I don't know if you've heard about it next month. I look forward to seeing everybody there. We're going to have a big IoT cabin there, so you can come hack there if you want. Or you can watch it from afar, but thanks everybody. Okay, so I'm here to talk about hacking IoT, and how many people have heard of DMC, the Digital Manufacturing Commons? Anybody heard of that? Okay, so there's a consortium in the US, and they're building, the main building is in Chicago, and they consist of all these companies right here, and including Dow, Rolls-Royce, McKinsey, General Electric. I believe we have some people in the audience that are from some of these companies, and what they've done is they're trying to democratize the industrial internet. And their idea was that if they build a platform for the industrial internet, and they make it available to everybody, they make it easy for everybody, and they have a bunch of manufacturing devices in a factory, and I have a picture of that, I believe. Let's see. Another picture. Oh, this is their website. If you go to their website, they have a model development kit, and this is kind of strange because a lot of our partners are also competitors, and they are part of this consortium, and I support everybody. I'm Switzerland. In the IoT field, I have to be Switzerland. So Microsoft and Amazon, we're built on Amazon, we connect to Microsoft, we build on Azure, and all these companies are involved with, mainly Microsoft, but they put tools up there. They have model development kits. So if you're in the industrial internet and you're interested in hacking and you want to start with a kit, you can go to this website. They have a web platform. They actually have manufacturing apps that they've built, and they've got real data, which was the premise behind the hackathon. We took real data. They gave us about 26 gigabytes. Well, there's the team. So we kind of assembled the team like 2 days before. This company called, this is a plug for a company called Robotics, and they do human-assisted robots. And they've integrated to our platform, so they called me up and they said, hey Charlie, we're going to go to Chicago, you want to join us? And I said, yeah, sure. They said, well, you have to bring all of your tools with you and you have to help us. And it wasn't just like me overseeing them, it was me actually working. So it was like a 72-hour hack, and we were very proud that we had 40% of our team were women. She was camera shy, but the Robotics team, they were great. They built the mobile app, and I worked on some of the other tools. But these are the machines that are sitting in their factory. So you could actually go visit these people in Chicago and take a factory tour and use the real data coming from the machines. And what they did was they took 26 gigabytes of data, and they open sourced it. So you can go get the data right now if you want. You can see the data that I actually used for the hack, and there were like 25 teams, I believe, there. And we took the data, and it was like common separated values files, and we just did a bulk import and converted it to JSON so we can import it in, ingest it into our engine. But there were 4 years of data, of manufacturing data, so you can go back to older machines, and they have most recent machines. So we focused on the newer machines because we thought it'd be cooler to focus on the new stuff. And they had 21 columns times 8 million rows. They had 75 different machines out there. And so we looked at the data. We used a very sophisticated model. Some of these guys were using R, and they were using some of the other analytics, open source analytics tools to analyze the data and try to infer patterns from the data. We used a very sophisticated tool called Notepad and loaded the entire 26 gigabyte file, or I think we had to chunk it up a little bit to get it in a Notepad, but we looked at it, we scrolled through it and said, oh, it looks like there's a lot of alarm data in there. So let's focus on alarm data. So the challenge is, so they assembled all these people in a room, and they said, see what you can do with the data. Here are the rules, and we weren't intending to win or compete or anything. We were just there to be supportive because we thought this was a good idea. And they said they wanted to look at loss of revenue due to machine downtime. So they said, hey, we have a challenge right now, and I hope I'm not stealing the thunder of the next presentation. It has something to do with the industrial internet, and I think the subject was the industrial internet is not really there yet or something like that. Well, that's true. We've got all these factories out there with all this data, and in this case there's 26 gigabytes of four years of factory data that nobody knows what to do with, and they can't infer any patterns from the data, and they can't do anything with the data. So we were challenged to go through and find methods to, in 72 hours, go through and figure out what you could do with the data. So they said, figure out how to minimize machine downtime. Look at machine status. You know, what's the status of machine? Can you see what state a machine is in? And how is that going to help the factory foreman? How is it going to help the humans in the equation? And how do we efficiently troubleshoot these machines that are down? So how many people here have dealt with the industrial internet or factories in the past? Does anybody really? Okay, a lot of you folks. So you probably know more about this than I do. So we, again, we took a mindless method of doing this. And this is the data, the sample data coming in. We did a conversion on it. And this is the JSON converted data. And so we see things like waiting for sync to PCU, right? So the machine powers up and there's some cycle time. So the way we looked at this is we needed a high volume, massively scalable ingestion engine to parse the data coming in and then make decisions about the data. Is this actually a problem or not? Is it an error or not? Is it a major alarm or just a minor alarm? So scrolling through the data and using human observation techniques and not anything automated. And then here's some more of the data. So this is what it looks like in rows. So hand terminal active, front panel inactive. So that's a piece of status information. So that's not the machine failing. And we didn't do anything with machine analytics either. So we didn't try to predict that something was going to fail. We just said, hey, it's failing, so take action. What we did was we focused on the human. And when I go out and visit customers, and it was said earlier that I do a lot of hacking, and that's pretty much, I've got the best job at Salesforce because I get to go out and work with customers, and we do a whiteboarding, and we say, okay, here we've got this device, let's hook it up to the internet, let's hook it up to the cloud. And it's all about getting it connected to the human, because that's what we do CRM, right? So it's all about how do you put the human into the equation. So we wanted to focus on the human, and this says, caution, this machine has no brain, use your own. This is an actual sign on a factory floor. It's trying to encourage people to use their head because the machines are stupid. Even though they're smart in some cases now, and they're getting smarter and smarter, they just spew out data and they won't save your hand. Well, they do. Actually, they do that now. They'll save your hand. So they have mechanisms to prevent dismemberment, which is really positive. By the way, is any of this translating? Is this translating to English, British? My American is horrible. Okay, so focus on the human side, focus on context. And there was a presentation earlier on how context is key, right? There was a state machine presentation on switching from state 1 to state 2 to state 3. I thought that was really cool because that's what we focused on for this. So what we did, and this is not meant to be a sales pitch, we have, this is really hard to do. Okay, so we got the data coming in here. This is the actual slide we gave for our presentation to the judges. And we have this engine over here that ingests the data, and it's a big state machine. And you're able to orchestrate the data and say, okay, if I see the machine go from state 1 to state 2, meaning if it goes from okay to broken, then I want to trigger an activity. So that's what this box does. And then, of course, we had to put Salesforce in there because they're a Salesforce contractor, and I work for Salesforce. So what we did was we created things like cases. We call them cases. You probably call them trouble tickets or factory incidents or whatever you want to call them. But that is how we connected the human equation back in. So the robotics guy built a smartphone app that can go into offline mode and also process the data in context. And I focused on doing the context switching. So ingest the events, process the warnings. This is just like that state machine diagram you saw from the previous presentation, right? Go from that state to that state to this state to that state. So make sure that the status of the trouble ticket is visible on the factory foreman's mobile phone. give the real-time visibility to the human, right? Help the human, assist the human fix the problem. And in some cases, escalate that problem using a workflow. So I've got a few minutes left. Let me show you the demo screenshots. So what we did was we built, this is a state diagram that we built using our IoT cloud thing. And it goes from normal to alarm, and then when it gets an alarm, it parses which alarm it is. So if it's they had different classifications of alarms. So what we did as we went through, we'd have the ingestion engine parse the type of alarm and just throw it into buckets. So we had the output go into, it just populated rows in the cloud basically with the type of error. And if we saw a trend, oh, hey, we're seeing lots of fault critical errors. So let's create another state for fault critical. So we just add states as we went along. So we iterated. So in the first version of this state diagram only had 2 states. It had alarm and normal critical. Actually, it had alarm. That's it, normal and alarm. And then we added normal critical, normal warning, fault critical, fault warning. So then we had to decide, okay, what do we do for the demo? For the demo, we had 8 minutes to show our hack. So what we didn't want to do is open up 8,000, we're going to push through, I think we pushed through about 3 gigabytes of data in 8 minutes during the presentation time, and we didn't want to open up 1,000 trouble tickets. So what we did was we decided which of these alarm cases would open up like 25 cases or trouble tickets and not flood 1,000 cases out into the cloud. So that's what we did. We picked fault warning. And this is really blurry, I apologize. And there's someone blogged about this, this hack. The High Robotics guys actually wrote a blog on this. And you can see a clear picture of this, but this is the thing, this is the real-time demo. And there's also a video up. They posted the video of all the teams. So if you want to see what all the teams did, and a lot of them used open source technology to do what we did, it might be instructive. They're all up on YouTube. And I'll tweet the link later, or you could just Google search for HackDMC, hashtag HackDMC, and you'll see the YouTube videos from all the teams. But this is the scrolling data, and this is going from alarm to fault critical was the alarm we picked. And these were actually opening up, these 25 cases in the cloud. And then when you click on a case, you can see it on the screen. Okay, this is a loss of air pressure at spindle bearings error, and the user app, the factory foreman app, had the same information, and they received an alert. And then during the demo, we showed how you push the button and you escalate it, and it goes through a workflow. So I am running out of time, but here's the app. I forgot to put the app in here. So this is a Huffman cooler general malfunction. And this is how long each machine, this is very important information. I interviewed some of the factory foremen, and they don't have this information. They have a blinking red light on a workstation in the factory when something fails. And there's no connection between the factory itself and the humans. So they have to go somewhere to actually see what data is coming from the machines and what activities have to happen as a result of these fault messages on the machines. So this one's sitting here waiting for sync to PCU for 15 hours, right? That would be a problem. So that should open up something for the human to take care of. The last thing we did was we used an analytics tool to go through, and we were able to do a heat map with the data they provided. So when you have a context-based switching engine, high-speed engine, that will take the data, parse it, and you can write rules around it, you can do things like push it out to take a bunch of events and push them out so they're easier to manage from an analytics standpoint. In this case, we're drilling down into one of the single machine faults and seeing what day it happened, how many faults are happening on a specific day. Is it related to a day of week or a type of machine? Is it a series of serial numbers? And you should be able to slice and dice that data. So let's see how much time I have left. Got 2 minutes left. Okay, so here's more streaming data. When the data streams in, we have like little debugging messages. We found, this is another lesson learned, when you're spewing data in at high speed, it helps to have an engine where you can have visibly available debugging messages, so you know when things go awry. And especially if you're going to push things out to another system, you don't want to spew out like 1 billion records to a cloud system and get charged for that. That's a problem. Okay, so there's more data. So here are the lessons learned. The human element is key, and I've got a kind of a higher level marketing slide on what we do with human elements, but put data in the hands of the humans and it's a home run that way. If you leverage the customer data, like if you use a CRM system, you're able to see who the customer is, you're able to see where they are, you're able to see the previous interaction history, and that's very key when you interact with humans. And if there's workflow up in the cloud, leverage that, right? So those of you who already had, your Salesforce customers, you already built your workflows. So make sure whatever you're connecting up from your IoT devices can leverage your workflow that's already in tools like Salesforce or Microsoft CRM or IBM's tools. Context is key, and of course, we think that a context switching engine is very important. So the idea should be, there was a presentation yesterday or the day before that they said, cloud computing's dead, or not dead really, but edge is really more important. And I agree, edge is more important. And I look at edge as heavy lifting, especially in my business. But, and I think more and more of the cloud stuff, this sounds like sacrilege, and we're a public company, don't go sell your Salesforce stock because I'm saying this, but functionality is going to move from the cloud down to the edge, right? We all know that, Moore's law. However, there's going to be functionality that needs to be in the cloud so you can do things like manage customer data, okay? Because the customer data is not most likely going to be in an edge gateway or an edge device. So things like sales history, service history, marketing history, web clicks on a web page, all that needs to be commingled with connected device data, and it needs to go into, again, that same context switching engine. That previous presentation, again, with the state machine on it, we call that a journey. That's a customer journey or a device journey, and those device journeys are important because everybody's going through a journey. You go and you go to the store and you're looking at a Fitbit Blaze. Actually, well, yeah, you might do that. So you're information gathering, and then you switch states from information gathering to arriving at the store. Or you're walking by the Carphone warehouse that gives you a notification that you should go in. You go in, and then it should know that you're standing by the phone device that you're interested in online. So web clicks commingle with state, commingle with devices, and everything else to bring the customer into the equation. So here's another sample. I just built this literally last night because the oil and gas folks called and said, hey, we have a vibrating pump in a factory, a refinery that's going bad. So here's one that shows the thing vibrates, it goes to a high vibration, opens up a case, and then maybe it'll sit after a while as a case and nobody takes care of it. No human takes care of that case, so it gets escalated. But in this case, it goes to waiting for tech, right? The tech is dispatched. And when the tech is dispatched, they close the case. If they try to close the case and the problem's not solved, you're still getting error messages, then don't let the technician close the case, because that creates another, we call it a truck roll in the United States. I'm not sure what you call it here, but they have to roll the truck again with the technician. That costs the company money. So leverage a state machine to keep the human in sync with the devices. And that's it.